Hey guys, welcome back to another video. I am back. So today we're going to be talking about the upcoming July 16th ACT exam and how a lot of you are probably taking it and haven't studied as much as you probably should have. So this is a guide to how to improve within a very short amount of time and hopefully get the score that you want. Definitely get the score that you want. Improving comes from doing a few key things, and I'm going to be talking about 3 that you should start doing today, and that'll really take you no more than a few hours just to start, and you'll make tons of progress, I promise. Also, when you do this stuff, make sure you stay consistent. Students who do this much work, this much, but have this much consistency, will improve much less than students who do this much work but with this much consistency, okay? So consistency is what helps you improve the most. That's what I've seen with the thousands of students that I've tutored, and it definitely will most likely apply to you as well. You have 3-4 weeks, set aside a certain amount of time that you devote each of those weeks, even each of those days, and do that amount of work. It could even just be 30 minutes a day, it could be 6 hours or 2 hours a week. You need to set aside a time and be consistent with that. The more the merrier. With that, let's get into the 3 things. Thing number 1, you gotta take practice exams. Where do you get practice exams from? You should buy the official ACT prep guide. It's on Amazon for like $30, $40. You can even buy one of the old versions from the last few years. The tests are still the same. Why do you need to take practice exams? Most students don't realize, but it's not just a way to like look at the exam and see how you like it. It's actually a way for you to learn the skills, try different strategies, get really good at your strategies that you're trying when it comes to timing, skimming, reading, different question type specific strategies. And the biggest thing is that these practice exams allow you to make mistakes, and you can learn from those mistakes because those mistakes are direct evidences of your weaknesses. And if you know what your weaknesses are, you can learn content to fill those weaknesses and not make those mistakes again next time, which means your score will go up. So the tests aren't just a way for you to see how you're doing, but they're a way for you to diagnose and make adjustments and learn content. Now, if you're looking for a place to actually learn the skills after you've diagnosed them, I would recommend looking over your practice exams, but also you might need a resource that teaches you the content. Kind of like Khan Academy does for the ACT, we do it on our website for the ACT. On our website you'll find thousands of problems, hundreds of videos that are much more in depth than the stuff that you see on this channel. So if you want to check that out, do it. If you want to get free help, there's stuff for free there as well. And there's also free tutoring that you can schedule with this guy if you want some one-on-one advice. So take advantage of the resources, paid and free. That's the first thing. Now, what do you do once you've taken practice exams? Is there anything else? Is that it? Just take practice exams and schedule a free tutoring session with you, Shaheer? Not quite. You need to do a little bit more, okay? The little bit more that you have to do isn't going to take much time, but it's really about how you approach the test. Reading and science versus English and math. 2 very different groups, 2 very different groups of sections, and the way you approach each one is going to be vastly different. If you approach them the same way, I don't know what the heck you're doing. English and math are skill heavy. You need to learn skills in order to get better at these sections. Reading and science are not skill heavy. There's no skills you really need to learn. There are some question types and that, those will fall into certain patterns. But really the way you get really good at reading and science is by developing a really robust timing strategy, skimming strategy, and most likely I would also recommend an annotation method that works for you. We have videos on our channel that go in depth on the 5 ways to skim on ACT reading, 3 ways to time on science. Watch those, pick a method, experiment with it on your practice exams for reading and science. And if it works, great. You found a method that works for you, ride that method to a higher score. If it doesn't work, try a different one. If none of the 5 methods work, then you're probably doing something wrong. Or I'm just stupid. So let me know in the comments which one. What else? As for English and math, I kind of already talked about how you learn skills and get better at them, so I need to come up with a new point number 3. I also talked about consistency, so I guess that might really just cover it. Yeah, that's kind of it. That's all I had planned for this video, so let's just make the rest of this a montage of me doing some ACT math questions. And if you have any questions, just send a message on the website. You can also sign up for our courses and tutoring if you want to get one-on-one help from me. Alright, see you, bye. How many distinct, real, positive integer solutions does the following equation have? So again, distinct, real, positive integers. Okay? So let's just first find all the solutions and then we can narrow it down after. So this gives us a solution of x equals 0. This gives us a solution of x equals 3, but it's repeated. So I'll just write it again. X equals 3, x equals 3. Same thing here. This gives us x equals plus or minus square root of 5 because it's a difference of squares, where b squared equals 5. A squared equals x squared. That means that a is equal to x and b is equal to square root of 5. Okay? And in this form, if you do this and set this equal to 0, you'll get 2 solutions, x equals plus or minus square root of 5. Here we get no solutions. This is these are imaginary. And here we get x equals -3, x equals -3. We get it twice. Okay? So distinct real positive integers. So what can we narrow down? Integers, these are not integers, so these are out. Positive, these are negative. Real, these are both real. Distinct, so we have 4 solutions here, but 2 of them repeat and then 2 of them repeat. So you can just pick one. We get essentially 2 as our answer. 55 is 2. So we have all these solutions, essentially 7 different solutions, 7 points, but only 2 of them are distinct real positive integers. Actually, there's 8 solutions, but only 2 of them are distinct real positive. 55 is B. Two ships are at sea exactly 100 kilometers apart. The 2 ships are also 175 kilometers away from the same lighthouse. What's the distance between the lighthouse and the midpoint of the 2 ships? So let's just draw this up. We have 2 ships here and here. Then we have a lighthouse that is 175 away from both of the ships. So let's label that. We have ship, lighthouse. 175, 175, 100. Okay. We're asked what's the distance between the lighthouse and the midpoint of the 2 ships. This is the midpoint. So how can we solve for this distance right here? You can do it with Pythagorean theorem. Clearly the answer options don't want you to do that. They want you to use sine, cosine, tangent. So what we'll do is we'll use sine, cosine, tangent. So I'm going to try to make a triangle here. In order to get this triangle made, we need to know, we already know the hypotenuse. We kind of know this side, and we need to find this side, okay? So in order to do that, again, like I said, we need to know this side down here. I know that that's 100, but this side specifically will be 50. It'll just be half of that because this is a midpoint, right? It's half. This is going to be 175. So we have that as well. In order to do this, I'm going to label an angle here that is theta. And let's call that, this is going to be our theta. And this is going to allow us to create a sine ratio opposite over hypotenuse, okay? So sine of theta equals 50 over 175. That means theta equals sine inverse of 50 over 175. You can calculate that. You don't really need to. The actual value doesn't matter. Okay. Now, if I do cosine of this angle, what is that? That's relating the adjacent side to the hypotenuse. So cosine of theta equals adjacent, which I'll label x, that's what we're looking for, over 175, the hypotenuse, which means x, which is the side we're looking for, equals 175 cosine of theta. And we know theta, because we have it written in numerical form here, 175 cosine of sine inverse of 50 over 175. Okay, and there we go. That is that right there. A function f of x is considered even if f of x equals f of negative x. Which of the following is an even function? So f of x equals f of negative x. For example, just to visualize, that means that if I took the function and I flipped it across the y-axis, the function would look the exact same. So for example, y equals x to any even exponent, y equals x to the second or y equals x to the fourth. These are all even functions because they're symmetric about the y-axis. Okay, that's really what an even function means. What this means, and that's what this is saying right here. If I flip my x values, where all the x values flip around here, essentially reflecting across the y-axis from x to negative x, the graph looks the exact same. It looks the exact same. That's why it's equal. Okay, so you can check that for all of these. For example, if f of x equals sine of x, and you want to check does f of negative x equal sine of x, just plug in a value for x and see what happens. So let's say x equals 3. Does does sine of 3 equal sine of negative 3? It should not, which means that this is not even. Cosine, it will work. Cosine of 3 equals cosine of negative 3. F of x equals this. You can try the same thing. Plug in a number, plug in a number, plug in a number. You'll find that these don't work. So B is your answer here. Two functions have the following forms. The maximum value of m of f is double that of g. The frequency f of f is double that of g. Which of the following is true? Note that c equals s equals 0, so we can cancel those out. So the maximum value of this is double this one.
the frequency of f, which is related to this, is double that of g. Now, what do we know about frequency? So we know period equals 2 pi over b, where b is this number in front of the x, 2 pi over b or 2 pi over r. Frequency is just the inverse of period. So frequency equals 1 over period, which is just b over 2 pi, r over 2 pi. Now, we know frequency is double. So if frequency essentially increases with this number. So if we know that this number b is higher, or r is higher for one of the other graphs, that means the frequency is going to be higher. It tells us the frequency of f is double that of g, which means that this b value is going to be 2 times the r value, okay? Since this maximum value, m, is double that of g, that means that a should be equal to 2 times q, okay? Again, these graphs, the reason we can compare the maximum value is because these two graphs, one is a sine, the other is a cosine. So sine graph will look like this, cosine graph will look like this. They're both centered on the x-axis. This is like the middle value vertically of both of these graphs, okay? Since they're centered like this, we can compare the maximum values and the minimum values, and they'll show the same relationship of double or triple if one is higher than the other, okay? So that's how that works, all right? B equals 2r and a equals 2q. This is out, this is out. The answer for this, we can also check D and E. So if we check D and E, let's see what we get. So the period of f is double that of g. Well, so the period of f is what? 2 pi over b. So this is going to be small, this is going to be larger, because we know b is greater than r, right? B is double r. So if b is greater than r, that means that this is less than this. The period of f is half of g. The period of g is quadruple that of f. This is not a factor of 4, this is rather a factor of 2, so 4 has nothing to do with this. Jasmine is taking a 5-question multiple choice quiz. Each question has 4 answer options. What's the probability she answers none of the questions correctly? Okay, so the probability of getting a question right is 1 out of 4. Probability of getting it wrong is 3 out of 4. So if you want to find the probability of getting 10 questions wrong, it's effectively the same as the probability of getting 1 question wrong times itself 10 times over. So it's just that probability to the 10th power. Okay? So you're going to raise the probability to the 10th power. This is what you do when you have a single probability and you want to find the probability of that event happening multiple times. Okay? So the probability of getting something wrong, 3 over 4. We're going to raise that to the 10th. Okay? And if you do that on your calculator, you'll get a value that is close to 0.056. Sorry, this is not to the 10th, this is to the 5th. There's 5 questions, not 10. Okay, so 5, 0.75 to the 5th. So it's 0.237. There's a 23.7% chance that you're going to get any given question wrong, or all 5 of these questions wrong on your test, okay? Which is corresponding to answer option A. Given the equation, if the period is doubled, which of the following is the resulting equation? So period is equal to 2 pi over b. I discussed period a little bit in defining it in this problem up here. So I'd recommend you check that problem out as well if you got this one wrong. The period is given. So if we double the period, that means we are taking b and halving it, right? Because the relationship here is, as this doubles, this halves. And if this is doubling, that means this has to be cut in half. This has to get smaller for this to get bigger. Okay, so if the period is doubled, the b value, which is effectively the number in front of the x, the coefficient in front of the x, has to decrease by half. Originally it's 4, so it would turn into 2. All those other options are wrong. That's the end of this exam.